Another important concept of FP is the concept of immutability. We have touched on this concept when we dealt with pure functions. Basically, with pure functions, we don't want to change or mutate any data outside the function. We call this a side effect. The data of our program represents the state of our program. So any side effects changes the state or data of our program. In FP, we strive to live by the ideal of immutability, meaning it can't be mutated or changed. If something is immutable, it is unchangeable. That is how we want to approach the data or state of our program. We only want to change state by functions meant to change it. Those functions are impure, but other functions should remain pure. Now, as you noticed when we were dealing with object-oriented programming, we were constantly changing the data in an object. We were mutating the state of that object and hence the state of our program. That was happening constantly, something we avoid doing with FP. Well, how do we create functions that bring in objects and process data on those objects without changing those objects? You already know how to do this to a certain extent, but let me reiterate and focus on that specifically. In the previous topic, we worked with reduce, map, and filter that were methods of arrays. Let's revisit that code. I want to show you how these methods also enforce immutability. All right, so the only part of the code I've included from the previous topics is the map, right here, the map method and the filter method. That's enough to show what I'm referring to. So when we use the map method on the scores array up here, and we process that as a decimal score, the results were returned and placed into this variable. And remember, it was a new array. And that same thing happened with filter. We eliminated those that were not greater than or equal to 70 and stored those in a new array. And it didn't affect this current array. We'll just look at that really quick just to reinforce that point. So if I come in here and take a look at the scores array, as we can see, everything is still fine there. Nothing has changed. If we take a look at the decimal score, we can see that one has changed. It's all decimal. And then finally, if we take a look at passing scores, or I should say pass scores, we can see that it only includes scores that are equal to or greater than 70. So 3 different arrays. So we haven't mutated this initial array. We returned a different array with the results that we want. And that is the process we use in functional programming. We don't mutate or change the state or the existing data that is there. And scores, this was the state of our program. We don't change that. We return a new array with the changes that we're looking for. Then, if we need to, if part of the purpose of our program is to change that state, we do that when we're done processing the data. So, arrays are objects, and these methods allow us to work with them without mutating those arrays. But what about common objects? When we were looking at pure functions, we learned about the rest spread syntax and how it could be used to create a copy or clone of an array. Let's look at that again because we're going to draw on that. So if I go back to our code here, so I'm going to paste this back in. This was something that we used when we were talking about the spread and rest operator. Notice how the score, I'm going to use the same scores array up here. We used a different one with the example, but notice how when we pass the scores array into this function, what it does to it is it uses the spread operator to create a new array. We spread out the values from the passed in array, place it inside of square brackets, creates a new array, and then we pop off a value so that we don't mutate what we started with up here. We don't mutate our state. Now, we can do the same type of thing with objects. In the FP world, we call this cloning. Whenever we're cloning any type of object, whether it be a regular object, array, or whatever it be, we call it cloning. And anytime we are working with objects in JavaScript, we should clone them in order to reinforce immutability. So I want to set up some examples to illustrate this. So I'm going to come down here. First, I'm going to create an object. It's simply going to be a user, and then inside that I'll just have a couple of properties. A name property, put my name there, and then attempts. That's the second property I want to have. Right now that's set to 1. Okay, so I have this object. Now, let's set up a function here that's going to update attempts. So update attempts is what I'm going to call it. It receives an object, and then it does something to that object. And what it does is it grabs the attempts property and increases it by 1. And then we return that object. Okay? So there we have it. Now let's see what happens. I'm going to declare a variable new obj, and I'm going to set that equal to update attempts. And what am I going to pass in? The user object that I created above. Now let's see what's going to happen here. So if I save that, I come out and I look at the new obj. Yes, we can see the attempts are now 2. So it did update the attempts. But when we look at user, notice that user had the attempts updated as well. So we're mutating the user object. We're mutating that state that's part of our application. We don't want to do that at this point. We want to have this function to be able to make changes without mutating that. So one way we can do this is we create what's called a clone function. So let me do that up here. I'm going to call this clone obj. And basically what it does is it receives an object. And then what it's going to do is return like this. It basically returns a new object. So we spread out the properties of the object that's passed in, place it inside of curly braces, and then we return it. Even though this is an arrow function, I needed to use the curly braces and the return statement, because if I just use these curly braces here, it would think it was identifying the body of the function and not an object. And so that's why I had to do it this way. But this will allow us to clone a regular object. So now, how do we use that? Well, before we pass that object in, let's clone it. That's one way we could use it. We also could make a call inside of this function. So now let's see what happens. Save that. Let's go ahead and take a look at new object. Sure enough, the attempts are 2. Did we change the user object? We did not. So our clone object worked for us. Now, I need to note that this method of cloning can be done in a number of different ways. I use the spread rest syntax, and that's only one way to do it. We can also use object.assign, and we can convert the object to a JSON string and then convert it back to an object. Both of those techniques will clone the object, just like the spread syntax did here. I'm just going to copy those in right here below, so they'll be here in the files. I've commented them out, but this is how we would do it with object.assign. Basically, we're copying everything from the object that's passed in into this blank object. That's the way that one works. Here with the JSON methods, first we stringify the object, so the object that's passed in is converted to a JSON string, and then we convert it right back to an object using parse. And so because we go from an object to a string back to an object, it has a different reference. It's a different object. It's not the same object that was passed in. All right. So both of those work for cloning objects. Now, something else to be aware of with this clone function. It only does shallow cloning. Now, what does that mean? Well, basically it means that if an object contains another object as a value for one of its properties, that level is not cloned. Only the outer object is cloned. Let me illustrate that. So I'm going to add a scores array here. Oops. Let's see, 90, 80, something like that. All right, so we have a scores array. And now I'm going to come down here and let's just try something here. I'm going to get a new object using the clone object function on user. And new object 2.scores. I'm going to access that scores array. I'm going to push in a new score here. Another 80. And then let's see what we have when we're done. So if I save that, if I come out and take a look at new obj2, so it's showing an array of 3. If I open that up, I can see that there are 3 scores there. I have the second 80 there. But what about user? User has that change as well. And why did that happen? Well, we cloned the outer function, but this array here, it's the same array. It's not a different array. The property here is referencing the exact same array in memory. So if we update that array, it gets updated everywhere it is referenced. And so that's why we're seeing that happen. And so shallow cloning would not resolve this. And the functions I've shown you are shallow clone functions. So what do we do in a case like this? Well, you can create a more sophisticated clone function where you check each property for objects and arrays and clone them and so on. Or you use a JavaScript library such as underscore or Ramda. Use one of those libraries, which they have a lot of these functions inside them already built in. And so the clone functions in underscore and Ramda, they do deep cloning. So it wouldn't be a problem with that. And if you plan to dive heavily into functional programming, I would recommend using one of those libraries. All right, we've covered a lot here. Cloning objects, a very important concept when you're doing functional programming. Let's move on.